All right, we're going to go ahead and find the greatest and least values for this cubic function on the interval from x greater than or equal to -2 and less than or equal to 5. So step one is we want to find the derivative function. So we'll bring down the 3, subtract the power, bring down the 2, subtract the power, and then drop the 5. So our derivative function is 3x squared minus 12x. And this is a quadratic function. Now we're going to find the critical values. We're going to set the derivative function equal to 0 and solve for x. Now we are able to use our graphing calculator to solve this, but I'm just going to go ahead and factor it. So I'm going to take out the GCF of 3x, and I'm left with x minus 4. Then I'm going to set each factor equal to 0 and solve for x. That's called the zero product property. So we would divide both sides by 3, and we get x equals 0. And then add 4 to both sides. So those are your two critical values. Now we're going to create our sign diagram. So here is 0, and there is 4 on our number line. Now I'm just going to write that derivative function down below, so I'm going to be using it later on. All right, so now we're ready to evaluate our derivative function in between those critical points. So I'm going to start with -1 to the left of 0, and I'm going to evaluate it for -1. And we get positive 15. Now let's go somewhere between 0 and 4. So I'm just going to choose 2. And we would get -12. So in between 0 and 4, we're going to get negative slopes there. And now let's try a number to the right of 4, so I'm just going to choose 5. And we get 15. So there's a positive number. So notice we go from a positive to a negative, and then from a negative to a positive. So we're going to have a max there and a min here at those critical points. So now we're going to sketch. We're going to type the original function into our graphing calculator. And here is what our graph of our cubic function looks like. Then from there, we can evaluate the original function at those critical points. So I'm going to choose 0 first and sub in. So 0 cubed minus 6 times 0 squared plus 5, giving us 5. So here is an ordered pair over 0 up 5. All right, now let's substitute -2 in. We would use a calculator, and we get negative 27. So that is our end point at negative 2, negative 27. So I should actually remove these endpoints here because it stops. Because our interval was from negative 2 to 5. Then we would substitute 4 in, the other critical point. And we get negative 27. So that is our other critical point, which is a local minimum. And then our last point, our end point, if we were to evaluate for f of 5, we get negative 20. So there is our end point. So to wrap up, the greatest value is, I'm just going to erase these here so you can see. This is your greatest value at x equals 0. So at the order pair over 0 of 5 is your greatest value. The least value is at negative 27, and it's at 2 places, when x equals negative 2 and when x equals positive 4. You get a negative 27 here and a negative 27 here when x is 4 and when x is negative 2. So those are your greatest values and your least values.